Today, on the Mysteria Archive, we're taking a journey through the weird, the wild, and the wondrous. This is the story of the cold spot Enigma. Have you ever wondered if our universe is truly alone, or if there might be something or someone out there just beyond the edges of what we can see? Well, buckle up, because today we're diving into one of the most mind-bending mysteries of the cosmos, the cold spot. Imagine a scar etched into the very fabric of the universe, a region so massive and so cold that scientists are scratching their heads trying to explain it. Could it be the aftermath of a cosmic collision with another universe, a telltale sign of the multiverse, or something even stranger? So, let's start by taking a trip to the beginning of everything, the Big Bang. A mysterious mark in the universe. The Big Bang, this colossal explosion, created the universe as we know it, leaving behind something we call the cosmic microwave background radiation, or CMB for short. Think of the CMB as the universe's baby picture. It's a faint, static-like glow spread across the entire sky, showing what the universe looked like about 380,000 years after it was born. Now, here's the thing. The CMB is supposed to be relatively uniform, like a calm lake at sunrise. Sure, there are slight ripples here and there, but overall, it's consistent. Except, it's not. In 2004, scientists using the Wilkinson Microwave Anisotropy Probe, WMP for short, noticed something weird, a cold spot. A massive, unusually cool region in the CMB, spanning about 1.8 billion light years. And to put that into perspective, our entire Milky Way galaxy could fit into this cold spot 100 times over. At first, researchers thought this might be a fluke, a random blip in the data. But further studies, including those from the European Space Agency's Planck satellite, confirmed it was real. And that's where the real mystery began. What could cause such a massive anomaly in the universe's structure? Okay, first off, can we talk about how casually scientists discover things like this? They're just scanning the sky and boom, oh look, a billion light-year wide cold patch. Imagine finding something that big and being like, weird. Meanwhile, if I lose my iPhone, I'll have a full-on blown crisis. But seriously, this cold spot is like the universe's version of a mysterious scar. And now we're all trying to figure out who or what left it there. Supervoids and empty space. And one of the first explanations scientists proposed was the idea of a supervoid. Now, what's a supervoid, you ask? Well, it's exactly what it sounds like, a massive empty region of space with fewer galaxies, stars and matter than usual. Think of it as a cosmic desert, vast, barren and eerily quiet. This cold spot sits roughly in the direction of a known supervoid called the Eridanus Supervoid, which is about 1.3 billion light years across. So, case closed, right? Not quite. While a supervoid might account for some cooling in the CMB, it doesn't explain why the cold spot is so much colder than expected. It's like finding frost in a desert. You'd expect it to be a little cooler, sure, but not that cold. Scientists have run simulations to see if a supervoid could create the cold spot, and the math just doesn't add up. That means we're left with two options. Either there's another explanation entirely, or something much stranger is going on. All right, so we've got a giant empty patch of space, and scientists think maybe it's just a really big supervoid. Sure, it sounds plausible. But then they run the numbers and whoops, it doesn't explain the cold. And at this point, the universe is basically saying, nice try, but I am keeping my secrets. Also, can we agree that Supervoid sounds like the name of a metal band? I'm just saying. The collision hypothesis. Now, let's get into the juicy stuff. The idea that the cold spot is evidence of a parallel universe. According to this hypothesis, the cold spot might be the result of a collision between our universe and another one. Imagine two bubbles in a bubble bath. Sometimes those bubbles bump into each other, leaving a thin, stretched out layer where they touched. Scientists believe something similar could happen with universes. The multiverse theory, which is where this idea comes from, suggests that our universe might be one of countless others. These universes could exist side by side, each with its own laws of physics, timelines, and realities. And just like bubbles in a bath, they might occasionally collide or interact. If that happened, it could leave an imprint, like a cold spot, in the fabric of our universe. But what does that mean for us? If the cold spot is a cosmic bruise from a parallel universe, it's part of a much larger multiverse, a vast interconnected web of realities. And who knows, Maybe these other universes contain alternate versions of us. Maybe there's a universe where you're a millionaire, or a universe where cats rule the world. Actually, that's our own universe about 5,000 years ago, but that's a different video for another time. Alright, so now we're talking bubble bath universes. Honestly, I love this idea. Not because I fully understand it, but because it's so wild. Imagine your universe bumps into another one and just says, oops, my bad, and leaves behind a giant bruise. And also, can we take a moment to appreciate how extra the multiverse theory is? It's not enough that we have one universe to deal with. Nope, there's potentially an infinite number of them. Okay, no pressure then. Quantum physics and the multiverse. To understand the multiverse theory a little better, we need to dip our toes into quantum physics. Don't worry, I will keep it simple. Quantum physics tells us that particles, like electrons, don't behave the way we'd expect. Instead of being in one place at a time, they exist in a state of probability, like a cloud of possibilities. This is called superposition. Now, here's where it gets crazy. Some interpretations of quantum mechanics suggest that every time a particle makes a choice, like deciding where to land, it creates a new reality. So, if you flip a coin, there's one universe where it lands heads and another where it lands tails. Multiply that by every decision ever made, and you've got a multiverse of unimaginable complexity. Some scientists think that the cold spot might be a clue that these parallel universes aren't just theoretical, they're real and they're out there. And occasionally, they might even interact with ours. Okay, quantum physics is officially the weirdest thing ever. And particles don't pick a lane, they're just chilling in a cloud of maybe. And now we're saying that every coin flip, every decision spawns a new universe. There's probably a universe where I didn't decide to make this video and became a professional juggler instead. But wouldn't that be something if we could actually meet other versions of ourselves? The role of dark energy and inflation. To truly understand the cold spot, we need to zoom out even further, to the moment just after the Big Bang, when the universe was expanding faster than the speed of light. This period, known as cosmic inflation, is thought to have stretched the fabric of space-time and smoothed out irregularities in the early universe. But what if inflation wasn't as smooth as we think? What if there were tiny ripples or fluctuations during this process that left behind anomalies, like the cold spot? Some researchers believe that the cold spot could be a remnant of an unusual inflationary event where the fabric of space-time stretched unevenly. And then there's dark energy, the mysterious force that's causing the universe to expand at an accelerating rate. Could dark energy have interacted with the cold spot region in some unique way? We don't know, but it's worth considering. After all, dark energy makes up 68% of the universe, and we barely even understand it. Now we're throwing dark energy and cosmic inflation into the mix. Honestly, the more I learn about the universe, the more it feels like it's just making stuff up to mess with us. Oh, you thought you understood inflation? Well, here's a cold spot to ruin your day. But in all seriousness, if the cold spot is tied to inflation or dark energy, it could help us solve some of the biggest mysteries in physics, or just give us more questions to argue about. Could it be a cosmic string? Let's take a detour into theoretical physics for a second and talk about something called cosmic strings. Now, these are hypothetical, ultra-thin defects in space-time that could have formed during the early moments of the universe. Imagine a crack forming on the surface of ice as it freezes. That's kind of what a cosmic string would be like, except it's 1 billion times thinner than a proton and stretches across galaxies. Some scientists think that cosmic strings could have a gravitational effect strong enough to distort the CMB. If a cosmic string passed near the cold spot region, it might have left behind a scar, a cooler patch of space where the energy distribution was disrupted. Now, here's the kicker. If cosmic strings exist, they could give us direct evidence of the universe's birth and the physics of its earliest moments, and they'd also provide a new clue in the search for a unified theory of everything. Okay, cosmic strings sound like something straight out of a sci-fi movie. Watch out, here comes the space-time crack. But honestly, this theory is exciting. It's like the universe is leaving breadcrumbs from its origin story. Also, imagine trying to find something thinner than a proton stretched across billions of light years. Good luck with that. The philosophical implications of the cold spot. And beyond the science, the cold spot raises some fascinating philosophical questions. If it truly is evidence of a parallel universe, what does that say about our place in the cosmos? Are we just one tiny bubble in an infinite multiverse? And if other universes exist, are they entirely separate from us, or could they influence our reality in ways we don't yet understand? There's also the question of purpose, and many people find comfort in the idea that the universe has a design or a meaning. But the multiverse theory challenges that notion. If there are infinite universes, then every possible reality exists somewhere, including ones where life never even emerged. And does that make our existence less special or more miraculous? All right, time for some existential dread. Now, the idea of a multiverse is both thrilling and terrifying. On the one hand, it's like amazing, infinite possibilities. On the other hand, it's like, wait, so I am just one of a billion versions of me. But hey, at least in one of those universes, I'm probably sitting on a beach on my own private island. Or maybe I'm an insect just about to be eaten by a frog. Better off looking on the bright side. The skeptics speak up. Of course, not everyone is on board with the parallel universe idea. And many scientists argue that the cold spot might not be anything special at all. It could just be a statistical fluke, a random anomaly in the CMB that doesn't require any elaborate explanation. Others suggest that our understanding of the universe's early days might be incomplete. Maybe the cold spot is telling us something about the nature of dark matter or the way galaxies formed. In this view, the cold spot isn't evidence of a multiverse. It's a puzzle piece for a bigger picture we haven't put together yet. And then there are the ultra-cautious scientists who just say, we don't know, and that's okay. After all, the universe is a strange place. Sometimes weird things happen for no reason at all. All right, leave it to the skeptics to be the cosmic party poopers. It's just a statistical fluke, they say. And sure, maybe it is, but where's the fun in that? I mean, the universe is already bizarre. Why not lean into it? Still, I guess they do have a point. Sometimes things are just weird for the sake of being weird, like pineapple on a pizza. No explanation, it just exists, even though it definitely shouldn't. What's next for the cold spot? The cold spot is far from a solved mystery, but scientists aren't giving up. New telescopes and satellites, like the upcoming James Webb Space Telescope and the next generation of CMB observatories, could provide more detailed data about this strange region of space. And who knows, as technology advances and our understanding of physics deepens, we might finally crack the code of the cold spot. And whether it turns out to be a supervoid, a cosmic bruise, or a sign of the multiverse, one thing is certain, the universe still has plenty of surprises in store. All right, so the cold spot is basically the universe's way of saying, stay tuned for more. It's like a cliffhanger on a really good TV show. Just enough mystery to keep us hooked. Honestly, I can't wait to see what future scientists discover. Now, maybe one day we'll look back and laugh at how wrong or right we were. Either way, it's going to be one hell of a ride. What if we're wrong? And let's play devil's advocate for a second. What if the cold spot isn't a clue about a parallel universe or a supervoid or even a cosmic bruise? What if it's something completely different, something we haven't even imagined yet? The cold spot could be a sign that our understanding of physics is incomplete. Maybe there's a force or a phenomenon we haven't discovered yet. Or maybe it's a message, a cosmic signal left behind by something or someone trying to communicate with us. Yep, I know. It sounds like science fiction, but then again, so did black holes once upon a time. So, what if the cold spot is the universe's version of a prank call? Hello Earth, this is space. You'll never guess what I left in your cosmic microwave. But seriously, this is why I love science. Just when you think you've got it all figured out, the universe throws you a curveball. Stay weird, Cosmos. Okay, I hope you enjoyed this one. It's quite a lot to get our heads around. And let me know in the comments below of any mysteries you'd like to see covered. This channel is for curious people just like us, where we delve into mysteries, conspiracies, the universe, and the supernatural. Okay, until next time, stay curious.